Hello everyone and welcome to episode 12 of the SAP TechByte series on RESTful Application Programming Model. Today we are going to explore one of the latest and smartest capabilities introduced in RAP recommendations. We all know value helps. User presses F4, searches through hundreds of entries and manually picks a value, which takes a lot of time in searching, filtering and choosing the right options. Moreover, during manual entry, two users can enter the same value differently. For example, first user can enter iPhone 17 and second user may enter Apple iPhone 17. So this leads to inconsistent data. Now imagine instead of forcing users to search manually, the application itself predicts what the user most likely wants. This is exactly what RAP recommendations brings into the ABAP cloud world. It supports business users in quickly and easily find the correct entries by providing standardized data entries for value helps. For example, when you create a travel entry trip to Paris, the application understands that your destination is Paris and can suggest the preferred flights, best hotels, nearby attractions, and so on. So recommendation transforms the traditional value helps into context-aware intelligent input assistance. This feature proposes field values based on user input, interaction history, and business context. Now let us see how to implement RAP recommendations. In the behavior definition of the RAP business object, you have to mention first the source field that the user enters based on which recommendations should be calculated. Secondly, define recommendation target fields for which recommendations are provided. And finally, the recommendation function to perform the logic to fetch the recommended values. These should be specified within side effects to inform Fiori UI that data changes require the recalculation of recommended values. In short, RAP recommendations are calculated and suggested to users based on entries in the input field. When the calculation on the backend is complete, the SAP Fiori UI is notified using a side effect. The UI then fetches the values from the backend and displays them on the UI. There are two implementation approaches possible now for RAP recommendations. First is the deterministic recommendations, which are rule-based suggestions generated using predefined business logic or mappings. Second is generative AI recommendations using the ABAP AI SDK powered by Intelligent Scenario Lifecycle Management or ISLM. In this approach, recommendations are generated using AI or semantic interpretation with the help of LLMs. The tabular return parameter of the recommendation function includes the recommended value, a score to assign ranking to the recommended value, and another field called suggested to specify the value suggested by the recommendation logic. I will be showing a demo for implementing deterministic rules to propose recommended values for a equipment purchase request form. Additionally, we will also see ABAP AI SDK implementation along with it in a slightly different way, not as a recommendation, but for providing a summary of a product feature using side effects. So let's get into the demo.
So this is the equipment request application where new employees or existing employees, whenever they are in need of a new device, they can come here and request for a new device. So for that, they have to click on create, and this opens the equipment request form. So it has an order ID, which is the next number in the series, and we also have category ID, which has three values: headsets, mobile phones and notebooks. For the demo, I am selecting mobile phones, and you can see that immediately the item text field turns blue, and there's a let's see what it has. So it has a text which says recommendation based on your business data is available, and there are two products or two devices that are recommended. So now why these two products are recommended and why only two products are recommended, all these things are based on the logic that we have written in the CDS view. So to find out what is the logic and how recommendations can be created like this, let's go to ADT. So the recommendation approach that we saw now is the deterministic approach. So let's see how the recommendation based on deterministic approach is created. So here we saw that I had provided a category ID value, and based on that value, item list was getting populated or values were recommended. So item text is a field which will receive the recommendations. So that's why I have to specify field recommendations item text. Now item text is getting the recommendation based on a source field value, right? So that source field value is category ID, and this is why I've written recommendation function. There is a function name which will contain the logic for providing the recommendations, and executed on field. Here we will specify the source field which will trigger the recommendation logic. So this should be specified inside side effects, so that whenever there is a change in the source field value, here the category ID, whenever it changes, it should trigger the recommendation logic, which is written inside get recommendation values function. So this is why this is written inside the side effects keyword, and as I mentioned, this is based on the deterministic approach. Now let us see how we can complete the definition here. So now we'll come to the item text notes based on item text later. But for the deterministic approach, again, we have to mention recommendation function and specify the function that will contain the logic to pick the recommendations. Now, once that is also specified, we can go inside the get recommended values function, which is the method that will have the logic to call the recommendation scenario and fetch the values. So here we are reading all the values and storing it in the internal table. Now we are also mapping the order ID and category ID fields. So this category ID will decide what values will be recommended for the item list. So before we go to the next method, like I mentioned, this is based on the deterministic approach, and the scenario that we are using here is created in Intelligent Scenario Lifecycle Management app, or the ISLM app. So I'll show the ISLM app quickly. So this is the ISLM app, and this is the scenario and the model that I'm using for holding the deterministic recommendations in the application. So this recommendation model is trained on the equipment request dataset, which consists of the category ID and the quantity and other values that are available in the dataset. So you can see here, once we upload the data set to the model, we have to train the model based on these parameters, the category ID and the quantity, and it will come up with a list of devices and a score against each device. So each device will have a score which will decide which is the most recommended, which could be the most recommended product out of the entire list. So this is what the recommendation scenario or model training does. Once the training is complete, we can deploy and activate the scenario. Later, it can be used in a program. Okay, so this is already done, and I'll switch back to ADT. So after capturing the category ID value, I'm calling another method which will have the actual logic of calling the recommendation scenario and fetching the values. So let me go inside that method. So here you can see I'm creating a JSON which should be passed to the recommendation, which will have the recommendation details, and this will be passed to the recommendation scenario to get the response back. Response again is the recommended devices. Now, the JSON consists of certain information, which primarily it is the top N2, which means give me 2 top recommended devices from the entire list. Now, the parameters that we are passing, one is the category ID, which is here in this example, it is the mobile phone, and we are also passing the quantity, which means the more the device that is requested more will carry a weightage or we will have a higher score. Now, here what happens is we have this JSON payload which says pick the top 2 recommended devices belonging to this device category mobile phone, and this JSON will be passed to the recommendation scenario to fetch the values. So we are passing this value and getting the response back here, and this response is broken down into three fields. So this response will have one, the device name or the device, two devices that we have requested as recommendations, the name of those devices, the score against each device, and there will also be a suggested field which will decide which will be the most suggested value. So here when we are breaking down the response, the first value will be the name of the device, which is the value here. Probability is nothing but the score of that particular device, which means higher the device with the highest score will have a more probability to get recommended. So based on that, we are updating the score, and then once all the items, so in this case 2 items which are recommended are updated to the final internal table, we are looping through that internal table, picking the first value only to update the suggested field as ABAP true, or which is updated as true. Because even if there are 2 items which are recommended, the first item will be the most probable or most recommended item. This is why we are passing it as suggested, and that appears first in the list and it will be defaulted. If we are creating without any selection, that will be the default value that will be picked up. Okay, so we have now received the 2 recommended devices. We have updated the details of the score and the suggestions, and now we can go back to the calling program. So within the calling program, we have LT items which consists of the 2 recommended devices along with their score and suggestions, suggestion value. And now the only task here is to map it back to the main device name. Here in the value help, we can update it as the item list. We can update it for the item list field with 2 entries. Okay. So this is how the predictive approach works. It is very simple. The data set decides which will be the most probable device that will be recommended, and we'll be calling the recommendation scenario and fetching the devices belonging to that category which will be having the highest probability score. So based on the number of values requested, instead of 2, you can also request 3. In that case, we will have 3 values in the value help. So this is how a deterministic scenario works. Now, let's go back to UI and select one of these products. So let's say I'm selecting iPhone 15 Pro. Okay, so as soon as I select this device, you can see there is a product review field that got updated with a summary or some details about that specific product. So now this is coming up from, this is based on the ABAP AI SDK, generative AI's approach that we had discussed. So inside the generative AI scenario, we'll be using ABAP AI SDK, which in turn will use an LLM to receive a prompt and provide answers like this summary of the item name or the text that is passed. So now let us see how this works. So for that, again we'll go back to ADT. Let's go to the behavior definition again. So for the second field or the nodes, we have specified that item text is the triggering field that affects the value that will be updated in the field nodes. So this again I have defined inside side effects to make sure that every change of value in item list will trigger an update for the field nodes. Again, one more thing we have to define here is the determination with a method name. Here I have specified product review on modify, and here we have to specify for the event create and the field that determines the change in the value, or the source or the triggering field will be the item text. So whenever there is a change in item text, the determination logic will get triggered due to the side effects, and then the product review method will get executed. So let us see what is there in the product review method. Okay, so Inside the product review method, it starts in the same way. We are reading the values and we are mapping the values that we require to calculate the notes, calculate the summary of that particular device. So here item text will have the name of the device. Here in this example, it was iPhone 15. And here we are calling another method. So get reco value from ABAP AI SDK. So this method will have the logic to call the ABAP AI SDK scenario, which in turn contains the model, and this has the LLM, which will finally give you the response regarding the query or the prompt that we had passed. So before we start with the logic, let us first see how a recommendation ABAP AI SDK scenario is created in ADT. So this is the scenario, like in the code you had seen this prod review SDK3 is the name of the scenario. It is of type SAP Gen AI and the technology is side by side and the usage type is stateless. So these are some of the parameters that we provide while creating the ABAP AI SDK scenario. Now this scenario in turn will have a model which will specify which LLM it will be using. So here this is the model name. And here you can see the large language model that will be used is GPT-4o mini. And this is the version which will be the version of that LLM that will be used. So you can either specify the prompts here within the ABAP AI SDK model, or you can specify it in the program. So in my example, I have specified it inside the program. So let's go back to the program. So we were inside this, we were here in the method. So if I go back to the ABAP AI SDK method, here we are creating a payload. Payload is nothing but the prompt that we'll be providing to the LLM. So the input text or the mobile phone name that I selected will be passed to this method get prompt payload. Let's see what is there in this method. So this get prompt payload is where the actual prompt is getting created. So here I have specified the model that will be used and the role, which is the role of the assistant. It is a product review assistant based on description of the product. And I have also specified the question or the prompt here saying analyze the type of product and highlight 3 to 4 specific feature phrases and display it in bullet points. So this is my prompt. In addition to that, I have also specified the max tokens as 1000 and I have also mentioned the temperature to be 0 to not have any random or imaginative answers from the LLM. So after this prompt is prepared, we are passing it back to the calling program in RV value. And now when we go to the calling method, our prompt is ready inside the LV payload field. Now, this is the scenario that I had created, the ABAP AI SDK scenario that I had created in ADT. So, I am creating an instance for this and I am passing the payload or the prompt to be executed to this scenario. So this scenario will receive the prompt which is inside LB payload and this prompt will be executed by the LLM that is inside the model. Okay, so after execution, it will have a response from the LLM again and then it will be passed to EV nodes, which is the returning parameter of this method. Now we can go back to the main method where it was called from. So here you can see this method will have EV nodes, which is nothing but the answer to our query or the prompt that we had passed to the recommendation scenario. And next task is to split it to specify it in the nodes. So the next task is to pass it back to the nodes field so that we can display the summary. So this is what is mentioned in the modify statement. And once that is done, we will be able to see the product summary in the product review field. Here the highlight is that we are able to create and activate and deploy the ABAP AI SDK scenario and model Within ADT itself, we do not have to switch between ISLM app and ADT to, create and deploy this model. So, the only thing here different is that it is using LLM inside the model. Instead of the deterministic approach, we had some strict rules. This is how, the answer would be. It is completely based on the data set, whereas here in the generative AI approach, we'll be creating a prompt and asking this question to LLM, and based on the response received from LLM, we are providing the response back to the program. Okay, so here the only thing that is different from the deterministic approach is that the way we have displayed it in value help, and here we have displayed it in a multi-line text. So this can also be created in the value help. The responses can be updated back to the value help, and it will also look similar to what we have in the deterministic approach. So only the approach is different, but the concept here is that there are two options to the user. They can use either the deterministic approach or the ABAP AI SDK based approach. So this was a very quick demo to show the different types of recommendation approaches that we have and how easily we can include recommendations in our applications and help business users from avoiding any mistakes while entering the data. Please do try it out and let us know in case you have any questions. We'll be back very soon with another episode of SAP Tech Bytes. Till then, take care.